count down and we're off and running. So again, this is Lean 1. This is an intro of a lot of just basic terminology and some of the basic concepts. When we did the Lego exercise, that demonstrated a lot of those concepts. So in this training, you'll learn the terminology and the background of some of those concepts, which is one-piece flow, how to balance the workload. One of the things you guys work on is one person was doing the 4 little pieces, and then the next person had one piece, and then they were sitting around waiting. And it's like, how do you balance out the workload? So that's a lot of the things that we'll look at in here. And we did quick introduction, but we'll do that again here real quick. My name, Brent Quicker, Lean Six Sigma Master Black Belt for the Lighthouse. And I've been here all of 2.5 years. Yeah, 2.5 years now. So what we're going to go over here, we'll go over the agenda is going to be the beginning. Where does it all start? We'll talk about the 7 wastes, and that's the one thing we mention at every training starts out with reminding everybody, what are the 7 wastes in manufacturing? And what's value added? Talk a little bit about what value added means in Lean. And then the Lean toolbox. That's, again, another term that we use in Lean quite often when we say, hey, what's in the toolbox? What's available to us to go work on that issue? So we'll go over what standard work is, what 5S is, TPI, that's transactional process improvement. That's basically everything that's not in manufacturing. If it's in the office somewhere, you would use TPI as a tool. Problem solving is around Six Sigma, which is statistical analysis. And that's looking at problems mathematically, trying to narrow down from all the mess that you're looking at. You're trying to narrow the problem down to a few possible root causes and then go after them. And then SMED. SMED means single minute exchange of dies, and that's setup reduction. So how to take a setup from an hour to 5 minutes. I watched things at Toyota where it took 5 hours to change the stamp mold out for a car hood from 5 hours to 5 minutes. So it's really amazing what can be done. So do I need to buy another machine at $1 million, or do I need to figure out how to change the dies out faster? Yeah. So an old saying something that was introduced to me a long time ago, if you always do what you always did, you always get what you always got. It's kind of similar to something that Albert Einstein said many years ago, which is in order to change the problems of today, you need to think different than you did yesterday. So that's the whole idea of what Lean is about, is to kind of introduce the concept and get you thinking a little differently than you did yesterday. So history of Lean, who could take delivery of raw iron ore, and that's the powder, that's mine, smelt it into parts, machine it, assemble it into a car. And they did it in one-piece flow, which is one piece, one part at a time, like we did with the Legos. They used flow manufacturing, where the product moved and not the people. And they did it in 3 days throughput time. From beginning to end, it was 3 days until a car drove off the assembly line. So who could do that and when? Obviously a big auto manufacturer. Ford. And about when do you think?
1912.
Pretty close. Yeah, 1913, Ford Motor Company was able to do that.
Very close.
And years later, they lost it. When Henry Ford, original Henry Ford, the first, left the business, they lost it. They started going to more batch and sending parts out to other manufacturers to be made for them. And they ended up losing all of that over time. So even back in Henry Ford's time, back in 1911, it was said that someday an intelligent nation has to awake to the fact that you have to scientifically study the motion in the business. So you really have to treat business and manufacturing as a science and not just let it happen. So there was back in 1911 an industrial engineering paper that was written about motion studies. So the fear was those that do not treat it as a science are going to lose that that supremacy in the manufacturing world. And that's what we started to lose in this country in the 70s and early 80s, when everybody else was just walking over us. Car manufacturers almost went out of business in this country. They had to get huge bailouts twice now from the government to stay alive because they were not treating their business like a client. So within all of that, there's 7 weights in manufacturing. The easiest way to remember them, again, is Tim Wood. He is the highest paid, hardest to find employee at any factory. So Tim Wood is transportation. How often do we have to move things around, move it from place to place? So every time you have to pick something up, take it to somebody else because they're far off in another department somewhere. Every step we take is 2.5 minutes. So if you think about that during the day, well, how many steps do I take? So my watch tells me now how many steps I take. I walk 2.5 miles a day. I have an office job. So you can only imagine how much walking you guys do out there on the shop floor at 2.5 cents a day. So we have employees here, we're paying $400 a week to walk. So that's how much walking they do here. It's a lot of money for non-value added work. Yeah. Inventory. Anytime you have something too much of something or too little of something is waste. If you're short parts, you lack inventory. If you have too much, we paid a bunch of money for stuff we don't need, and our overhead is 18%, I believe. I think about 18%. So whatever we buy something for $1, we're paying $1.18 just for the pleasure of holding it, unless we use it and get it out the door. Motion. So anytime you guys are moving around or having to reach for things, within motion weight is look weight. So how often you have to stop and go, oh, I can't find this, I can't find my tool, I can't find my hammer, you're looking around for it because it's lost. You know, that's motion waste. And that can be as high as 20% of your time is spent just looking for what you need. Waiting. Anytime you're waiting for the process before you, if you remember Legos, how often you guys were waiting for the person ahead of you. Over processing, again, that's waiting for somebody to sign off, approve. I have to send it over to first part check, and then I have to wait. So that's over processing. Then overproduction kind of wraps a little bit of everything in there. I'm producing too much inventory. I'm causing a lot more transportation and motion for stuff that I don't need. I don't have to sell right now. I only need to sell 20, but I made 100 and I'll put 80 on the shelf. So that's overproduction. And then good old quality defect. That's, again, the most expensive one out there because it took everything to get that part out to the customer, and then they send it back and we have to write them a check. So we have to take the money they gave us and we have to give it back. And then we have to go produce it again. And then that puts us in that risk of, well, you made that part bad multiple times. Next time we'll just give it to somebody else. You guys just struggle with it. So it really has an effect on business. Yeah, and let me tell you that we get measured on it. And we meet monthly with Boeing on every little part that came back. Why did it come back? And what happened? The whole history of the non-compliant. So value added and non-value added. If you think about it, everyone thinks, oh, well, everything I do is value added. You know, I work and I get parts done, or I do my processes. People in accounting, you know, say I do my thing and I put it in my outbox and everything's of value. Well, as a customer, if you got your bill from Fred's auto repair shop and it looked like this, and hey, I'm going to get charged for almost 6 hours of work, but I'm looking at coffee break and inspect it. I had to wait for parts for a while. It's like, I don't want to pay for that. That's not of any value to me. It's stuff that you guys had to deal with, but I don't feel like I should have to pay for it. Well, that's in your bill. You just don't see it. So if you looked at it and said, well, I'm willing to pay for working on my car, and that's about it. Maybe doing the inspection to figure out what's wrong. But other than that, I don't want to pay for the rest of that stuff. So when you look at it in a lean fashion, is there's things the customer is willing to pay for, things the customer doesn't want to pay for. So how do I get rid of those things or minimize those things as much as possible? So in Lean, what happens a lot is, what do? We go out on the manufacturing floor because we can see it, we can touch it and feel it, and it's really easy to just say, oh, here's what we can do to shorten that up or make that more efficient. Well, a good 90% of the time spent at a company has nothing to do with manufacturing. It's in the support of. So there's a lot of opportunity and all that work that goes on to support manufacturing. So we have to look, and that's non-value added. Our customers don't care how long it takes us to process a check or, fill out a work order. They don't care. All they want to know is, hey, you work on my part, you got it to me on time at a reasonable cost. So there's a lot of things to work on around that one guy in manufacturing that we're all leaning over to see how fast he's doing things. A lot of opportunity. So the way to look at non-value added is, if it's non-value added and it's unnecessary, just get rid of it. And it sounds simplistic, but you'd be surprised how many times you go out and look at a process and somebody's doing some form or paperwork of some kind and turning it in, only to find out that it's being ignored on the other end or going right in the trash can because they eliminated that process 2 years before and no one told you. So there's a surprising amount of those things going on. There's times where it's non-value added and you can eliminate it if possible, but it's actually necessary. There's some paperwork we do have to fill out, some steps we do have to go through. They're not really adding value to the part. So you try to do a Kaizen or improve on those as much as possible. And if you can eliminate them, then you do. Then, of course, anything of value added and it's necessary, then you improve it. You try to improve it, but there's a lot more opportunity over on this side of the fence. So the Lean Toolbox. We mentioned standard work, 5S, transactional process improvement, problem solving, which is that analysis side, and then SMED, which is that single minute exchange of dies or reduction of setup time. So we'll get into a little bit about what each one of those is. The standard work, that's the elimination of waste by developing a standard or a pattern of repetitive work. So it's very scientific motion studies, and it's our relationship between ourselves and the machines or the work that we do, the tools we use. So if you think about it, just like on a football field, if the goal was, hey, we throw the ball out in the field and you guys just try to get it across the goal line, go, and nobody knew what their rules were or what their job was, that'd just be utter chaos out there. Might be kind of fun to watch, but it just would be utter chaos. So what standard work is every player knows their role. I know what my job is, I know what your job is. You do this, I do this, we work together, and hopefully we end up with a winning team. So that's what standard work does. There's an analysis of all the steps it takes to get a job done, break it up into equal shares so we all know what our roles are, and then we go after it. So it's that establishment of a pattern or routine for repetitive tasks, and it's the relationship between you and your environment. So if you, again, think about that Lego exercise, the first one or two might have been awkward, but as soon as you got to the fourth or fifth one, you kind of got a rhythm or a pattern going. So if it was different every time, what would happen?
No rhythm.
Yeah, you're no rhythm. You're just every time you're trying to figure it out and go, okay, so you're learning new every day. In a very short period of time, usually 7 times, the human mind establishes a pattern, and then you don't even think about it anymore. You're talking and doing your job and not even looking at what you're doing for it. So that's the importance of that pattern. And the reason you want to establish the pattern of the habit is you leave and the second shift guy comes on. He needs to be doing it exactly the same way. If things change, then you all change together. So it enables us to align resources to meet customer demand, because once I know we have a pattern or a routine, I know how long it takes. There's no guessing about how much is going to come out of that department that day. So it makes managing easier. It gives me a basis for improvement because I know what normal is and I know what abnormal is. So if I know with the three of you, I get 100 a day, I expect that. If I got 80, okay, something went wrong. I need to go investigate. But if I got 100 every day, then I know, hey, that's what I expect. I know what the rhythm is. Safety can get built in a little easier when there's a pattern. And then the product is built the same way every time, and it protects the customer from variation. 80% of our boo-boos that go out the door are because we did not do it the same way. We didn't follow procedure. We varied from the procedure in some way or form. We didn't inspect something the way we're supposed to, and it gets out the door. So a lot of our errors here are not because we accidentally drilled the hole too big, or we just did not follow our standard procedure. So there was no procedure change that had to happen. It was, we should have followed what we had documented. So that's our biggest one right there. So within standard work, we're going to do some scientific study in an area. We've done that many, many times here. At least 25, 26 time studies have been done in this building now. And the things we look at is takt time, cycle time, and standard width for that work in process. So the things that we recorded during the Lego exercise was operator cycle time. How long did it take you to do your job? Width, we counted how many pieces you had in process at the end. And then what we did not record during the Lego exercise, is one of the most important things for the customer, is takt time. So what's takt? Takt is the frequency in which the customer wants a product. It's just how much does the customer want, is takt. So takt, the word takt, means rhythm. The Japanese do not have a word for rhythm, so they had to borrow it from the German. So that is actually the German word for rhythm or beat of music. So takt just means how much does the customer want? I want 100 a day. So he says I want 100 of those every day, so the takt is 100. Now the takt time is how many, what do I need to make time-wise? So to get takt time, I have to look at my daily available time. So I'm not used to for 8 hours a day. And how long does it take you to make one? And I can look at the customer demand, 100 units, and I can come up with a time. So it's pretty easy math to be able to say, hey, I've got you for this many units a day, I need 100. That's how many we're going to be able to produce. So takt time can change based on customer demand or the available work time. So if you come along and say, hey, I can only work 4 days a week, okay, my takt time has changed now. I need to have more done. So my operating time, my available time, so we always say an 8-hour day, but we don't actually work an 8-hour day. You have breaks and cleanup time, so you have to keep all that in mind when you're looking at available time. Divide that by customer demand, which is the takt, and I get my takt time. So we'll go over what that math looks like here in a minute. Operator cycle time. That's the time it takes one operator to build the product all the way through, so from beginning to end. So I have to time out how long it takes you to build the product, start to finish, go back to beginning again. If there's any inspection time, packing, walking around, I got to record all of that time to come up with what your operator cycle time is. So what that'll help us with is to figure out where the waste exists, because we're timing the walking, the loading, packaging all separate. And it allows us to segment the work later on. So once I know all of the different steps, then I'll know where I can draw some lines and break it, like we did with the Lego exercise. If one person did a certain step, well, they were totally overloaded. So we were able to separate some of that out and give it to somebody else. So that's what understanding operator cycle time allows you to do, is to draw lines and divide up the work a little easier. And then some cycle time examples are, if I've got my little U-shaped cell, I might have my total operator cycle time is how long it takes this person to go from 1 all the way to 11. But if I've got multiple people in there, I've got operator cycle time for each person. So the time can be a little different. If we say, hey, what's the cycle time of that product? Well, the cycle time might be a half an hour to go all the way through the cell. But the operator cycle time will be 1 is 10 minutes, 2 is 10 minutes, 3 is 10 minutes. In a perfect world, you'd like everyone to be perfectly even. So there's total cycle time, operator cycle time. And then WIP. WIP is that minimum amount of stock you want to keep in there to keep the line moving. Because the one thing you don't want is in the morning, if you've got a 7, 8 operators there, you walk in the morning and your operator 1 starting, again like Legos, operator 1 started, and what were the rest of you doing? So, yeah, you were all waiting. You're kind of waiting. So if you came in the morning and everyone had one piece in front of them ready to go, the bell rings and you all start and production just starts going.
You didn't push better. I go to one side and
Yeah, it allows the line to take off right away. So there's work left at the machine, there's buffering between curtain operations, those sorts of things. So but it's the minimum amount of stock to make sure production's flowing. Another term for it is when the line's wet. So you have the line all set up. At the end of the day, it's kind of a habit. Everybody goes, oh, we've got to clear production all the way to the end and leave the workbenches all cleared out for the morning. And it's like, no, you want to keep that measured amount of inventory in front of every operator so they can all start out again and not have that wait when they come back in. So again, WIP would look something like this. I've got a bunch of machines, I've got material in different spots in the cell. So I would leave at the end of the day, and this is what it would look like. It should look like this, where I've got parts sitting around in different machines ready to go. So when I come in the morning, I fire everything up and it just starts going. If I let everything clear out and I come in the next morning, it might be hours before I get finished this again to start feeding whoever else takes parts after me. Now, curtain operation, I think we mentioned it in the other training. For curtain operation is anything that's outside the cell or outside of your view. As I give it to somebody, it goes away and it comes back maybe 2 weeks later. So painting, we do a heat treat, hardening of metal here. There's a lot of things we do that we send away and then it comes back a few weeks later and goes right back into the cell again. So the curtain is just kind of from the Wizard of Oz. Just don't look behind the curtain. I don't know what goes on back there. I don't need to know. It just goes in and it comes out. So here's an example of looking down at a U-shaped cell. And I've got 2 operators in here. They're building rockets. This was a real work cell, by the way. It was down in San Jose, California. And they actually build rockets down there, the ones that get strapped up underneath the cargo planes that help give them that little extra boost to get off the runway. So there's 2 operators assembling the rockets. And this is how they split up their work duties. So the first operator would do the first step. He was able to turn around because it was a U-shaped cell, do the final step, do a quick test, and then put the rocket into finished goods. And then the second operator worked in his end of the cell. And when they were extra busy, they would throw a third operator in there, and they would just divide the work up a little differently.
Yeah. More people would say, more need to divide,
Yeah, you just have to, in standard work, once we understand how long does it take each step to be completed, as you throw people in, you're able to divide the work up and split it up. And a U-shaped cell allows you a lot more options to be able to move people around. If this was a straight line, I wouldn't have any choice at all. I couldn't have you go from the beginning and run down to the other end to do something. You're pretty much stuck right where you're at. But U-shaped cells like this allow you a lot more options of moving people around and dividing the labor up.
More people can faster process.
Yeah, so if all of a sudden the customer said, hey, if Acme called and said, hey, I need twice as many rockets next week, I can throw a third or fourth person in there, and I would look at the timing, draw a line to divide it up evenly, and go to each operator and say, okay, you're doing these steps, and then stopping.
Yeah, I go and ask people,
So part of standard work, or part of trying to establish a pattern, is 5S. 5S is about the organization and of your tools in your work area, and it's about eliminating that look waste. So by having everything put away in an orderly fashion and having to go back every time after you use it, you establish a pattern to where you don't even think about where your tools are. You just reach for them in a very short period of time. So there's some really good examples here of the toolbox with the black foam cut out like I have here. All the different tools are labeled where they go, that's form fit. Shadow board is real common, where it's just a white pegboard and they draw the little black line around the tool. It doesn't work real well for us. We still have a bunch of them in the building. But it's common in other facilities, just not here. It just doesn't work for us here. It only works well if you have site. And then another example here of 5S, where you do allow somebody some personal items or some personal space. So here was somebody that wanted to have, hey, I want my hand lotion and some tissues and things there. So you do allow for some personal space, but as long as it's marked out, labeled, this is what you get, and that's it. So the 5 S's, there are actually 5 Japanese words that start with S. The rough translation is sort, set in order, sweep, standardize, and then sustain. So those are the 5 S's. The first one is the hardest. So yeah, the very first one, believe it or not, is the toughest one. And that one is all about just getting rid of the junk, trying to decide what you don't need. So yeah, but it's literally stripping everything away. So the way I like to do it, and the thing is, 5S, I hear this in a lot of facilities. It's not a cosmetic cleanup. I hear a lot of facilities that they say, oh yeah, we do 5S. We have 5 minutes at the end of the day and we clean up. And it's like, that's not 5S. That's not standardizing and sustaining it. That's just sweeping the floor. That's the sweep in the middle. And that doesn't even mean it's literally sweep. So if you think about it, sport teams are pretty good with 5S. Everything comes, because they travel. Everything comes rolling out. It's all laid out in the same way every time. Surgeons are crazy 5S experts. You think about it. The tools are laid out on the little tray. They're shadow boarded. They print the shadow board per surgery. They all come out of the printer. They lay each one on a tray, put a tool on each one, and then seal it in plastic. And then they're stacked in order. So the surgeon starts at the top, goes to the bottom, everything's in order of how he uses the tool. They all go back on the shadow board to make sure they don't leave one inside of it. And firefighters, the same fire truck is at 2 different locations. Everything's in the same place. I can go from station to station. I don't have to relearn where everything's at. Businesses seem to be the last ones to kind of catch on to this organization. So where does it apply? A little bit of everywhere. This was a previous boss's office. He was a CFO of the company. Stuff everywhere. But if you went to him and said, I need a P&L statement from 2 years ago, he'd go, boink, and he knew exactly where it was. But when he was gone, we couldn't find anything to walk it with. So he totally turned that around, and it ended up being a beautiful example after that. This other bench over here with all this stuff everywhere, that is actually at a facility in Redmond, Washington, where I work, and that is where cochlear implants are. All that little mess right there. So as a manager, I would go to that bench and wonder, is that person busy? Are they behind? Do they have a reject? What's going on? Do they have all the tools they need? But again, 5S, sort. Again, very, very difficult to do when you're trying to decide, well, what do I keep? What don't I need? What do I need here? Easiest way to do it is just take everything away. Just take it all away from the operator and say, okay, now we're going to set an order. So you do your job, and as you do your job, we'll hand you the tool that you need. And once the process is done, anything that the operator didn't ask for goes away. Get rid of it. Oftentimes they have a tool there for that. Every once in a while something goes wrong, and I have to have this mallet to smack it or a screwdriver to pry it loose. Well, that should be when they ask for somebody, ask for a supervisor. Because you need to fix that problem instead of giving the operator the tool to get around it, is make it to where it's really obvious when there's a problem, and then you'll go and fix it. But don't make it too easy to get around a problem. Sweep after you set everything in order. That's not sweep the floor, that means sweep with your eyes. As a supervisor or manager, once everything's set in order, I need to kind of watch it for a little bit. The operator's going to say, well, yeah, I do need this tool, or here's something that's the wrong tool, it should have been something else. So you kind of watch it for a little bit and make sure that it's working. Then you standardize. You take that and you replicate it everywhere you can. Because now I've got a standard set. And then sustain is you reach that fifth S when you get to the point where you don't even think about it anymore. It's a habit now. Everywhere we go, we just do this. Don't even think about it. We don't even call it 5S because it's just what we do. So that's when you reach that sustain point. So some of the terms we like to throw around, Kaizen, most common one, and that just means continuous improvement. Kai is continuous, Zen is improvement. So whenever we say, hey, we need to do a Kaizen on that, well, that term you'll hear a lot, just, yeah, we need to do an improvement on that. Hijunka, when I was asking you guys in the Lego exercise, like think about how you're going to level out your workload, is Hijunka. Anytime you're leveling out the workload. Oftentimes it's when production or orders are coming into the shop floor, and I've got 200 one day and I've got 50 the next day, and you can kind of smooth those out. So it's like, well, I'm going to do about 180 a day, and one day I'm going to have a little too much, one day might not be enough, but I'm smoothing production out. It makes things a lot less crazy on the floor. We mentioned poke-yoke earlier, and that's mistake proofing. If I've got a jig, a fixture, I've got something that does not allow me to make a bad part, doesn't allow me to pass it on to the next operator. And then Kanban, that's that signal or that signaling system. We have that in mailboxes, we flip the flag, that's a Kanban. I put 2 bottles of empty milk bottles out my porch. The milkman leaves 2 full ones. So that's a Kanban signal. We do a lot of those here. We've got the lights that you see everywhere. Those are they're called and-on lights, but they're Kanban. That's a signal. If it's yellow, it says, hey, I got an empty bin. If it's red, I got 2 empty bins, so I'm more important than the yellow. If it's blue flashing, it means I need you right now. And then Muda, waste. Anything that's waste that stops production is called Muda. So the 7 wastes, that's the 7 Muda. So some examples of poke-yoke that we use quite often. But the poke-yoke that was built into those was you can't put them in the wrong way. If you tried to put it in upside down, it stopped you. The drive wouldn't accept it. USB cables, a lot of different cables. I've only got one way I can plug these cables. I can't put them in backwards. Poke-yoke design. That little tether that keeps me from losing my gas cap. How many of those have you seen laying around the road or on the roof of people's cars as they're driving down the road? So that's a poke-yoke that keeps you from losing that. And then transactional process improvement, and that's standard work for the office. So when you're trying to decide, well, do I go and do a time study standard work, or do I do a transactional process improvement? The difference is, you ask that question, is like, is there a time? Is there a time that I have to do this process repeatedly? And if there isn't, like hiring somebody, we never know when we're going to have to hire somebody if the situation's not repeatable. Because, hiring a president and hiring somebody in accounting, completely different processes. It's basically the same. We're bringing somebody in the door. There's a search for, and it's much, much different. So it's not a repeatable process. So if we want to make that take less time, make it a little more efficient, we're going to go after it with transactional process improvement. We're not going to go and do time studies So a typical TPI Kaizen is you do a process map of the current process, and that's literally just drawing it out. Then you look at improvements. We look at ways to do cause and effect. We do some brainstorming. You're basically just looking at the waste that's involved. You map out how you want the process to be. You can apply some controls or some measures, and then you implement. So it's pretty straightforward. You're just not doing the time set part of it, but you're doing everything else. How do we do it now? What's the waste? What should the future look like? And then how do we maintain it? How do we keep it that way? So that's what a process map would look like. This was a map of how we ordered labels from one of our vendors. From beginning to end, which is down here, that was a 2-week process to get a quote on the label. So the customer would call and say, I want this label. 2 weeks later, we would return the call and say it'd be this much. And they would say, I've already ordered them from somebody else and I already have them in the building, applied to my product, and they're heading out the door. So we had to squeeze that 2-week process down into 3 days to be competitive. So we process map out every step of the process. Everywhere you see the diamond shape, that means somebody had to stop and make a decision. And look at how many of those are in here. That's that over-processing way. So every time the color changed, that means it went to a different department. So if you look at it now and think, oh wow, look at all the color changes, all the diamonds, there's a lot of handling going on. Nothing was automated. So that was what we mapped out. So decision points of the diamond, we had the color legend down at the bottom. And anywhere we had that little orange dot, we said that's what we're going to go work on first. Once we had this mapped out, then we ended up with a to-do list out after that. So within that, you use a lot of problem-solving Six Sigma tools. There's a lot of things involved there. Pareto diagrams, C&E diagrams are really common. Process mapping, what you just saw, and then some value stream mapping. What and why? It's just a really rapid approach to solving a problem, and it's usually focused on quality or variation of some kind. And the whole thing is what it's looking at is just to look for a root cause. Oftentimes we see a problem and we go, oh, well, it's because the inspector intended. Well, that's not the root cause. The root cause is 3 or 4 layers below. So if you do the analysis, you would say, well, the root cause is the operator didn't do what he was supposed to do. And yeah, it went through multiple people. It didn't get caught before it went out the door. But fix the problem down here at the root cause level, not up here. So a lot of times we go, oh, we need more inspectors. And say, well, no, if you do a POCIO with the operator, then the problem is eliminated. So that's what problem solving will look at, is those sorts of things. So some problem solving applications, you might look at first pass yield, warranty issues, sometimes inventory imbalances happen a lot on something. So you would do some analysis there. Customer invoice errors, cash flow. So there's a lot of different tools within the Six Sigma tool range and problem solving that you would use across those sorts of issues. But it's really just to look at how do I analyze something, try to figure out what some possible root causes are, and then go after it, and not just shotgun approach and try different things. So again, a typical problem solving event, basically the same as a TPI, is I'm going to document my current process, look at my inputs, look at ways to reduce the errors that are happening, look at my root causes, and again, make my improvements, and then figure out how to lock them down. And oftentimes that's with, again, I'm measuring, I got control plans, more training involved, that sort of thing. So they're pretty much the same between a TPI and a problem-solving event. We're just using different tools. We're using more Six Sigma tools on the problem solving. A lot more analysis goes on there. So here's that fishbone diagram. We really don't know what we're going to work on. So we say, hey, the effect or the problem we have is this. And then we go and say, well, method, machine, man, material measure, and Mother Nature. Those are my categories. So you're going to start brainstorming with some Post-it notes, and you're going to say, well, here's what I think causes the problem, and it relates to materials, and that's where I put my Post-it notes. So it's a way to make everybody feel a little bit more comfortable about brainstorming. Because if I ask Harry to say, hey, what do you think the problem is? He's probably not shy at all, and he'll shout out 3 or 4 ideas. I might go to you, and he'll go, I'm quiet here. Not that you're like that, because I know you're not. But a lot of people get their biggest fears speaking in front of others, so they're not going to come out with any ideas. This is a safe way for you to write down your ideas and just go stick them up on the wall. And then you can use them for other things later on, like a process map. Like this. So here's a process map of a coffee maker that we had, again, over at Box Maker. So I'm keeping my friends over at Box Maker. We had a couple engineers over there that, for the life of them, could not remember to put the basket back into the holder when they were making coffee, and they would walk away. They would just make a big puddle of coffee everywhere on the floor. You would think a degreed engineer would be able to remember to put the coffee basket back in there. Yeah. So as a joke, we had a Kaizen on how to make coffee, and we made out our process map here. So a process map, you don't want to put too much detail in it, but you want enough to be able to point at it and say, that's where the problem is. Enough steps to where I could look at it and say, okay, yeah, if I follow these steps, I can make coffee. There's enough information there, but also enough to be able to point out where the problem is. So since placing the coffee filter in the basket was one of our issues, but the biggest one was placing the basket back into the holder. Now what I call this is it's a crime scene now. Because of all the times it happened, 11 times, we looked at it and said, well, what was the cause? Well, 7 of the 11 was they forgot to place the basket back into the holder. So I have a little 7 in it, how many times it happened. So I can look at that process map now and say, well, that's obvious. What we need to figure out is that. How do we make it to where the coffee maker doesn't even turn on unless the basket is in place? So now it's a crime scene map. How many times did the crime happen? Elsewhere. And then a little bit about SMED, or that setup reduction. Single minute exchange of dies is actually a Toyota term, and you record all of the steps required to set up a machine, break them down into categories, and figure out which ones you can remove or eliminate. And then the biggest thing of it is which ones are external or internal. So one of the tricks we did was, instead of having the tools up on a nice tool board, a nice shadow board, is we removed the shadow board, mounted the tools right on the machine. So the tools are scattered all over the machine, and use them all where they need them. So they didn't have to go back and reach one. So it's about quick changeover, and it's also called setup reduction, rapid changeover. And the whole idea is to increase manufacturing flexibility, because now I have more machine time, reduce my lead time, and I can reduce my inventory because I don't have to set a machine up and then run large amounts anymore. So it's primarily used in machining where quick changeovers are required. Toyota, Craftsman Tools use them extensively. I worked for Craftsman Tools most of my career, and Craftsman Tools would celebrate a 1-second improvement on a setup change. That was how important it was to them. They could reduce 1 second off the setup change. They would have big people parties in their department. So it was a very big deal with Craftsman Tools. The other experts at setup reduction is the guys in the pit crews, the racing. If you want, and the experts at standard work in general, there's really a setup reduction. Anything that can be done to speed up the process to get that machine back in business again, get the car back on the track, they're masters of it. They all have their work balanced out evenly amongst each other, and they practice year-round. Those guys are really amazing at setup reduction, what they've done. Single bolt to remove a tire instead of 5 or 6. There are a lot of different things like that. The fuel goes in. There's a release valve to allow the fuel to drop in, like 5 gallons in 2 seconds. Drop into the vehicle that fast. really impressive, the different technologies they've come up with. So what's the big deal about setup reduction? Why? Well, when the machine's down and it's not running, it's in setup time mode. We're not making any money. Our machine overhead here, I believe, is $325 an hour. So when the machine's running, we're making parts. Hopefully, we're making more than $325 an hour on the machine. But when it's shut down, we're paying $325 an hour for that still machine. So the shorter the setup time, the more money-making time we're getting out of the machine, more output coming out of the machine. So if the machine's running, we might be making $1,000 to $1,200 an hour on a machine. So the less setup time and the more run time, the more money we're making off that machine. And if you look at that and say, well, I'm getting so much more business, I need to buy another machine. 100,000, give or take, for one of those machines out there. If you can shorten your setup time, increase the run time on a couple machines, it might eliminate you from having to go buy a $100,000 machine. No other questions? You guys give me a holler if you do, or you see me wandering around. Don't be shy about stopping and asking questions.